astronomers have discovered the nearest potentially habitable planet outside our solar system. But the new-found exoplanet, a so-called super-Earth, lies 31 light years away, and 1 light year is about 9.5 trillion kilometres. To discuss this and the week's space news, I'm now joined by astrophysicist and cosmologist at ANU, Brad Tucker. Brad, good to see you. Thanks for joining me.
No worries. It's been an exciting week for planets and, well, beyond our own.
There have been, look, a lot of discoveries this week. Let's talk first about this new one. What more do we know about it?
So this is kind of one of the first big results from what's called TESS. So this is the new satellite that NASA's built. So I was actually just in the US at this conference, and it's trying to find planets in our local neighborhood. And it's specifically looking for these habitable planets. So we know that it's in the habitable zone, the zone where liquid water can exist. And it's also, as you said, relatively nearby. I mean, 30-ish trillion kilometers sounds like a lot, but it's practically next door. And we think that even though it orbits really close to its star, it could have liquid water, and we think it rotates and it has day and night. So for all intents and purposes, it can support life. So it's going to be the next target for follow-up missions trying to measure its atmosphere and actually see, is there something or could there be something living on this planet?
What are the conditions that could make it potentially habitable?
So, I mean, one of the things is we're pretty biased towards looking for things like our own. So we look for things that could have water in its liquid state. So, you know, not something really cold like Mars or really hot like Venus. We also look for things that contain an atmosphere. Obviously, we think things need to breathe. So, you know, Mars has an atmosphere, Venus, Earth, you know, even some of the outer planets have atmospheres. So we want to see, can it have an atmosphere? And also importantly, does it actually spin, right? You can imagine if a planet only has one side of daytime and one side of nighttime, that's probably not habitable unless there's something that doesn't need to sleep or something that doesn't need energy. So those are some of the early conditions that we look for to even see, could a planet host life, at the very least like something like Earth?
Also this week, the Hubble Space Telescope has found a, quote, very weird heavy metal planet, and it's also been described as hotter than hot. Why is that?
So it's a class of objects called hot Jupiters, and so what they mean are big planets really near the sun or really near that star. And the closer they get, the hotter they get. Now, this one is so close, we think that it's actually getting pulled or tugged off of it. So the closer you get to something, gravity pulls it away. Now, the closer a planet gets to a star, the gravity of the star can actually pull or strip the atmosphere away. And they actually detected lots of what we call heavy elements or metals. So things like iron, nickel, a lot of those heavier things beyond oxygen that are existing in this atmosphere, and we think that star's pulling it away. And so as it gets closer, it gets hotter. So this is something that's literally almost 10,000 degrees hot, and it's this really weird shaped thing. And it orbits so close that it's actually only orbiting 1.5 days. So a year on this planet is 1.5 days. So you'd be very old. No offense.
No offence to the planet itself. Now, also this week, on the topic of discoveries, a different 3-planet system has been found with a few planets that seem to fill the missing gap in planet sizes. Brad, what does all this mean?
So, you know, if we look at our solar system, we have these 4 small rocky planets, Mercury, Venus, Earth, Mars. Then we have those big gas ones like Saturn and Neptune and Uranus. But we've also found these super-Earths, these larger Earth-like planets, as we just talked about. But there appears to be they should come in all shapes and sizes. We should see things that are bigger than these super-Earths, but not quite the size of gas giants. So more gaseous, but also not as big as, say, Neptune. And this 3-planet system, which is about 73 light years away, has 3 of them. So it kind of has a Saturn-like planet, but instead of having beautiful rings and this big gas environment, it's actually a bit smaller and has what we think is a rocky core. So what we're really just starting to see is, as we take the census of our local neighborhood, we're really seeing that planets come in all shapes and sizes, and we're starting to confirm that now with observation. So we live in a really exciting place of the galaxy, at least exciting to me.
I think exciting to a lot of us too. And just finally, Brad, NASA has announced it will partner with a number of private companies to get back to the moon and get to Mars. Why have these companies been chosen?
So it's quite interesting. So, there is this goal to get to the moon by 2024 and further afield, and they've had lots of successes. And so various companies have been chosen that have made really good strides in their technology. So SpaceX and Boeing are some of the bigger ones that you might know, but there's lots of small players looking from communications to satellite relays to even starting to extract things in space, because one of the goals is actually going to have to extract water, mine things from the moon. So NASA's really saying this isn't going to be like 50 years ago where this is really a private or a government-led endeavor. We need all the help we can get to make it a really collaborative effort. I think this is an interesting sign. Space has really shifted and private sector's making big inroads. And it actually means there's probably going to be chances for the private sector here in Australia to use their expertise to actually get some of these contracts and help NASA get back to the moon by 2024 and further afield to Mars. So you can see this is where something like the Space Agency is going to really work having it in Australia to connect our industry with these big goals of getting to Mars.
2024, still quite a few years away. We did, of course, in the last few weeks celebrate the 50th anniversary of the Apollo 11 landing. Just how big of a mission is it to get everything organised to try and go back to the moon?
Look, it's tricky. Apollo worked because it took 9 years and they put $180 billion at it. The budget is not there this time, and the time frame's shorter. So I think this is a clear signal that NASA says in order to achieve its goals, it really needs help. So I think the only way 2024 is going to happen is with private endeavors participating in these NASA missions. Mars is a lot trickier. Not only is it further, but it takes longer. There's a lot of human aspects that are coming into play there, and it's really uncharted territory. We've never done anything like this before. So it's kind of a nice sign that says space is really becoming accessible, and there's a lot more work needed, and the U.S. government needs help. NASA needs help, and I think hopefully Australia will come to their aid.
Fingers crossed. It would certainly be wonderful to see. Brad Tucker, appreciate your time as always. Thanks for joining me.
Take care.